Hey guys, I'm Lemon. In Module 2, I'm going to introduce the centrality calculation and its application in RStudio. First, let's have a briefly review. What is centrality and what do we learn? It has been introduced by other members through this picture, and I also want to have a briefly speaking. I think it represents a person or an organization's occupation, especially in the social network, and the connections among each element. The second one is centrality measures. It's mentioned earlier that about centrality, there are about three main methods for social network centrality analysis and two measurement elements. They are degree centrality, clonal centrality, and betweenness centrality. For two measurements, they are centrality and centralization. In fact, the centrality shows the TAT program or consistency throughout the graph. It represents a graph centrality, while the centralization is a degree of a node that at the core of the network. Then, please allow me to introduce three methods by my own understanding. It will benefit for the next introduce of the centrality calculation. It's really brief and short. The first one is the degree centrality. It's the parameters of the actor's importance when one actor is in direct contact with many other actors. So it can be generally expressed by in degree. Next one is the betweenness centrality. For example, if an actor is located on many communication paths and has the ability to control the interaction of others, it means communication with others needs to pass through this person. So betweenness measures the degree of the control of the resources by this actor. So if the point is on the path of communication of other points, we can say the centrality of this point is more high. The last one is the clonal centrality. A point does not rely on the strength of other nodes to disseminate the information. The closer the actor is to others, the less the process of dissemination depends on others. Therefore, when the distance between a node and the other nodes in the network is very short, it means this point is the center point of the whole. In the third part is the centrality calculation by the simplified view. And this is the simplest diagram for the centrality calculation. And this one is the degree centrality. It's the feeling of being referred by how many tasks. So it uses the task divided by possible tasks. From this picture, you can see like point A, the possible task is the number of node minus 1. It means n minus 1. So the total task is 3. And for point A, there is only one arrow that point to A. So the degree centrality of A is 1/3. And for point B, you can see there are two arrows that point to B, and the degree centrality of B is 2/3. The next one is the betweenness centrality. It refers the feeling of being passerby. So it's calculated by divided the passer time by the total task. And here, the total task is how many paths it can go through. And you can see from the picture, for point A, it can reach from A to B, or from A to B to C, or from A to B, C, and D. So the total ties is 6, and this number can be calculated from by this equation. And from the pass time, and then you can list each point pass at here. And from the pass times, you can see there is no data for A to use as a medium. So the between centrality of A is 0 divided 6 is 0. And for B, you can see B are used for 4 times, 1, 2, 3, 4 as a medium. So the centrality of B is 4 divided 6 is 2/3. And for point C is the same as B. Point D is the same as A. The last one is the clonus centrality. It refers to the feeling of proximity, and it's calculated by the number of node minus 1 multiplied the inverse of total distance. And actually the total distance, it means and it's also from this picture, you can see from A to B there is only one path, and from A to C there are 2 paths, and from A to D there is 3 need to go. So the total distance for point A is 6. And so the overall distance, it means A plus 2 plus 3 is 6. And the clonus centrality of A, you can see at here, it's 0.5. And for point B, you can see the total distance is 4. So for point B, the clonus centrality of B is 3/4. So above all are the basic of understanding of this equation, and this is the official equation of 3 centrality. In this equation, the degree centrality, n is the node and E is edges, and the verticals V. So the meaning of this equation is the same of what I just introduced in the simple graph. It means the number of ties that point to the node divided the total ties. In the between centrality, the PGK is the total number of Gauss disk paths between 2 edges nodes, and the PGKI, it means the pass times. And in the last clonus centrality equation, the DIG is the distance of 2 nodes that can be reached, and N is the same meaning of that in the degree centrality. So above all are the introduction of centrality calculation. And so thank you.